Alright guys, it's now time to check out a worked example on some of the stuff you've just seen. That is how to work with quadratic functions in turning point form. Now in particular, we're going to pay special attention to detail when talking about translations, reflections, dilations, and all the other mumbo jumbo that we've just spoken about. Alright, we're also going to have a look at how to sketch the graphs of quadratic functions when given to you in this form. So let's check that out.
Alright, so this question says, for the function y equals negative 2 bracket x minus 3 squared plus 1, state any dilations, translations and reflections that have occurred and whether the graph is a maximum or a minimum. And part 2, sketch the graph of the function. So let's have a look at this. The very first thing we need to do is rewrite out the rule, so let's go through and do that. So I've got y is equal to negative 2 bracket x minus 3 squared plus 1. And the question says state any dilations, translations, reflections that have occurred. So before we do that, let's just go through and circle our A, B and C values. So this here is our A value, this here is our B value, and this is our C. So we'll circle those just so we know which one's all linked up here. And let's have a think about which affects what. Now if we think about it, our A value as we went through before, that's the dilation factor. So we can say there's a dilation factor of 2 from the x-axis. Now even though it's a negative 2, we just call it a positive dilation factor because you can't actually have a negative one. What the negative actually does is it reflects in the x-axis. Okay, coming over to our B value now, well what's occurred? Well, it's been translated 3 units to the right because of the negative here. So, translated 3 units to the right. And our C value, well that's moved the graph up 1, so it's been translated 1 unit up. And the last part of the question there says state whether it's a maximum or a minimum. Now because it's a negative graph, the graph's actually going to look like that, so therefore it has a maximum turning point and is a maximum. Okay, so the next question says sketch the graph of the function. Okay, so what we need to do is go through and follow these 3 steps up here. Step 1 saying convert into turning point form if needed. Well, it's already in turning point form, so we don't need to do that. Step 2, locate the coordinates of the turning point. Alright, well let's go through and do that. Our turning point is going to be at the point 3, 1, because it's the opposite of the b value, so it says negative 3, so you get 3, 1. Step 3 says locate the x and y intercepts. Okay, well for the x-intercepts, we make y equal to 0. So let's go through and do that now. So we get y is equal to negative 2 bracket x minus 3 squared plus 1. Just writing out the equation first of all. Now let's go through and make y equal to 0. So you get 0 is equal to negative 2 bracket x minus 3 squared plus 1. Go through and basically use BODMAS to undo everything and find the x value now. So you get negative 1 over here is equal to negative 2 x minus 3 squared. Divide both sides by negative 2 now, gets us 1 half is equal to x minus 3 squared. Square root by sides now, so you get plus or minus the square root of 1 half is equal to x minus 3. And then we're going to get 3 plus or minus square root of 1 half is equal to x. So therefore, x is equal to 3 plus the square root of 1 half, or x is equal to 3 minus the square root of 1 half. Now when I go through and plot those points, I'm going to end up having 3 plus the square root of 1 half, comma 0, and 3 minus the square root of 1 half, comma 0. Alright, so let's go through and plot those points now. Now it's really hard to find the coordinates of 3 plus the square root of 1 half, so what you need to do is just find out what it's approximately equal to by using your calculator. Now when you do that, what you get is the coordinates 3.71. So we now know roughly along this x-axis they're at 3.71. So that there is 3.5, so 3.71 will probably be around about here. Alright, but what we actually do is we write down the exact coordinates of 3 plus the square root of 1 half, comma 0. And of course we do the same again for 3 minus the root 1 half. Once again, putting that into our calculator, what you'll find is if you do it, you'll get the answer of 2.29. So that's roughly around about here. And of course, once again, you write out the full coordinates of the exact value, so that is 3 minus the square root of 1 half, comma 0. Alright, so now that I've got my 2 points there, what I need to go through and do is find my y-intercept. Now to find my y-intercept, I make x equal to 0. And I go through and solve. So let's put that into the equation now. So you get y equals negative 2 bracket x minus 3 bracket squared plus 1. Make x equal to 0 now. So you get y is equal to negative 2 bracket 0 minus 3 bracket squared plus 1. Therefore that gives us y is equal to negative 2, 0 minus 3 is negative 3 squared plus 1. Y is equal to negative 2, negative 3 squared is 9 plus 1. Y is equal to negative 2 times 9 is negative 18 plus 1, which is equal to negative 17. So the coordinates of our y-intercept are 0, negative 17. Let's go through and plot that now. So you get 0, negative 17 is just here. And we write that in. And of course our turning point is at the coordinates 3, 1. So that is all the way up here. And we write that in here, 3, 1. Okay, so we've got all of our points now. So what we need to do is just go through and sketch it, making sure that we go through each one of the points that we've found. So start at the turning point and go all the way down. Make sure you draw an arrow at the end so we can show that it's actually continuing on. And we do the same for the other side. Now my graph's not perfect because I'm using a tablet, it's quite hard to draw on, but of course when you've got a piece of paper it makes it a lot easier. And it's now that time of the lesson again where you need to press pause and attempt the following question. That is for the function y equals 2 bracket x plus 1 squared minus 8. State any dilations, translations and reflections that have occurred and whether or not it's a maximum or a minimum graph, and sketch the graph of the function. Remember, when you're done, press play so you can check your solutions out against mine. Alright guys, so welcome back. First thing I've done is I've gone through and written out y equals 2 bracket x plus 1 squared minus 8, because of course that's the formula that we've been given. Now let's go through and write out our a, b and c values. So our a value is 2, our b value is 1 and our c value is negative 8. So when we have a look at our a value, well, that's going to mean that we have a dilation factor of 2 from the x-axis that you can see here. Alright, is it negative or positive? Well, it's positive, so you don't need to talk about any reflections or anything like that because there's none that's occurring. So we just talk about the dilation factor. Now when we have a look at our b value, we can see that it's been translated 1 unit left because it's going the opposite direction to what you would normally think, because it's positive 1, it's going the negative direction. And our c value is saying that it's being translated 8 units down. Now because a is a positive value, we actually have a minimum graph, that is a graph that looks like that. And of course our turning point is at the coordinates negative 1, because you get your b value negative 1 here, and our c value is negative 8. So the turning point is at negative 1, negative 8. So let's go through and plot that first of all, shall we? So negative 1 and negative 8 right here. And we'll write in negative 1, negative 8, like that. Right, the next one says find the x-intercepts, well, to make y equal 0, so I've gone through and I've written out the equation once again, made y equal to 0, and start to solve for x. So because we've only got one type of x, it means we can use BODMAS to undo it. So to do that, I just add 8 over here, divide both sides by 2 gives me 4, and then you get 4 is equal to x plus 1 squared. When I square root both sides, like you can see here, I get plus or minus the square root of 4 is equal to x plus 1. And of course, square root of 4 is equal to 2, so you get plus or minus 2 is equal to x plus 1. And then we subtract 1 off both sides, so you get negative 1 plus or minus 2 is equal to x. Now I've split that up into x is equal to negative 1 plus 2, and x is equal to negative 1 minus 2. Negative 1 plus 2 is equal to 1, 0, and negative 1 minus 2 is equal to negative 3. Now I've split that up into two parts. I've got x is equal to negative 1 plus 2, and x is equal to negative 1 minus 2. Now of course, when I get negative 1 plus 2 you get 1, and when I get negative 1 minus 2 you get negative 3. So that gives me the coordinates 1, 0, and the coordinates negative 3, 0. So let's go through and plot those now, shall we? So you get 1, 0, and negative 3, 0. Finally, it says find the y-intercept as part of step 3. So you've got the y-intercept, so we make x equals 0, so you go y is equal to 2 bracket x plus 1 squared minus 8, once again writing out the equation of the line, and then of course you substitute in x equals 0, and you go through and simplify, so 0 plus 1 is 1 in the brackets, then you get 1 squared is 1, then you multiply it by 2, gets you 2, and your minus 8 to finish off with gets you negative 6, so the coordinate of that point is at 0, negative 6, and we go through and we plot that. 0, negative 6, and of course I need to write out the points here as 1, 0 and negative 3, 0.